Hello and welcome back. We're solving another problem today from the ALEKS learning system. So the problem says liquid hexane reacts with gaseous oxygen to produce gaseous carbon dioxide and gaseous water. What is the theoretical yield of carbon dioxide formed from the reaction of 75.0 grams of hexane with 378 grams of oxygen gas? Alright, so to begin with, we're definitely going to need to write out this chemical reaction in chemical equation form. Just a reminder, this would be one reactant, reacts with would mean plus this other reactant, to produce would be the arrow, and then carbon dioxide and gaseous water are the products. So let's go ahead and write that out. I'm going to combine this into a simpler equation. So to do that, let's just count the number of carbons. So there's one carbon here, there's 4 carbons here and 1 carbon here, so that's 1 plus 4 plus 1 is 6 carbons. And then hydrogens will count as well. 3 plus 4 times 2 is 8, so that's 11. 4 times 2 is 8, plus 3 is 11, plus 3 is 14. So we have C6H14, and the problem tells us that's called hexane. That is going to combine with oxygen gas, O2, to produce carbon dioxide gas and water. Alright, so we're ready to begin. We first need to balance this chemical equation, so we'll go back and forth. This one's a little bit tough, but if we apply a neat little trick, it'll be quick. 6 carbons, we need to get 6 carbons over here, so we'll put a 6 in there. Then we have 14 hydrogens over here, so we need 14 hydrogens there, so 7 times 2 is 14. Now we run into a little bit of a snag. 6 times 2 is 12 oxygen, plus 7 times 1, 7 oxygens, so that's 19 total oxygens. So how do you get 19 total oxygens over here? Well, the trick is that you can balance it with a half. If you multiplied 9 oxygens, that would only be 18. 9 times 2 would be 18, or 10 times 2 would be 20. So we're going to put 9.5 there, and then that'll be balanced. 9.5 times 2 is 19 oxygens on this side. The problem is we're not allowed to balance using halves or using fractions, so we need to change these all to whole numbers. So to get balanced, we'll just double everything. So replace the 1 hexane with a 2, replace the 9.5 oxygens. 2 times 9.5 is 19, 2 times 6 is 12, and 2 times 7 is 14. So there are our new coefficients: 2 hexanes plus 19 oxygens plus 12 carbon dioxides plus 4, or reacts to form 12 carbon dioxides plus 14 waters. And we're ready to go. So this looks pretty ugly. Maybe we want to just rewrite it for ourselves for neatness sake. Right below, 2C6H14 plus 19O2 reacts to form 12 carbon dioxides plus 14 waters. Alright, now we're ready to go ahead and dig in. What we said is that we're going to be reacting 75 grams of hexane, so 75.0 grams of this, with 378 grams of oxygen gas, 378 grams of oxygen gas. And we want to know the theoretical yield of the carbon dioxide. So that is the question that we're trying to answer. So let's dive in. The way we'd set this up is we'd start out with each one. So we'd start out with 75.0 grams of C6H14 and 378 grams of oxygen. And we need to go ahead, and what we're going to be trying to find in each case is the theoretical yield, or the grams of CO2 that's produced. So in each case we'd see this one, there's enough, we'd be answering the question that how much CO2 could be produced from C6, this amount of C6H14, and what's the maximum amount of CO2 that could be produced from this much oxygen. And whichever one is least, that means that ingredient or that reactant runs out first. That's the limiting reactant, and that's theoretically the amount of CO2 that we could produce. So to get started, it's a standard mass stoichiometry problem. So we're going to start by converting grams into moles. And for this, we need the molar mass of each compound that we're going to be using. So I've already added up hexane's molar mass, and it's 86.178 grams per mole. Grams of hexane per 1 mole of C6H14. So that will help us convert from grams of hexane into moles of hexane. The next step would be to try to convert into moles of carbon dioxide. That comes from the chemical equation. 2 moles of hexane. It says in the chemical equation, react to form 12 moles of carbon dioxide. So now I've converted grams to moles, moles of one thing to moles of the thing I'm trying to find. The last step is just to convert moles of carbon dioxide back to grams of CO2. I previously added up the molar mass of this. I get that 1 mole of carbon dioxide is equal to 44.009 grams of carbon dioxide. Now we can plug that into our calculator, multiply across the top, divide across the bottom, and we get 230 grams of carbon dioxide. Could be produced if all C6H14 reacted. So when all of this reacts, we would have that much produced when this runs out. Now we'll do the same thing with oxygen. The molar mass of the steps are exactly the same, so the molar mass of oxygen is 31.998 grams of O2 per 1 mole of O2. The mole ratio to convert from moles of oxygen to moles of carbon dioxide is 19 moles of oxygen to 12 moles of carbon dioxide. Then last, we would apply the same molar mass of carbon dioxide, 44.009 grams of carbon dioxide for every 1 mole of carbon dioxide. And that would give us, when we multiply across the top, divide across the bottom, that would give us 328 grams of carbon dioxide as the answer. So now we have to decide which one is the theoretical yield. So when all of the hexane has been used up, we get 230 grams of carbon dioxide. When all of the oxygen get used up, we get 328 grams of carbon dioxide. So we can't get to 328 grams because hexane has been used up at the time we produced 230 grams of carbon dioxide. So we call that the theoretical yield. Theoretically, that's the amount of carbon dioxide we could produce, and the limiting reactant is the hexane. It's the one that runs out first when we've produced 230 grams of carbon dioxide. So there you have it. That's how to solve for the theoretical yield of chemical reactions.